Hello again, you sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist, DT, from Weather Risk, your captain of chaos, your colonel of confusion, your commander of catastrophe. Let's talk about this week in weather, and we have a lot to talk about on this December 26th, I guess it's almost December 27th now, and just wanted to wish all my Christian friends a Merry Christmas. And with a lot of topics here, obviously we are in a mild and wet pattern. The cold cycle we had at the beginning of the week going into Christmas is now over for the most part. Again, there continues to be strong indications of a major pattern changes occurring after January 1st and the big Ohio Valley low that goes up into the eastern Great Lakes and up the St. Lawrence Valley. That's the beginning of the change. There is strong model agreement, and we'll get into this, that the MJO, the Mattian-Julian oscillation feature, is going to go into phase 8 and phase 1 in January, in the first half of January. Now the pattern favors an eastern U.S., maybe even an East Coast low. There's a window here, January 6th to January 12th. And we've been saying that for a while. And it looks like the favorable pattern could last through at least January 20th. But I'm not certain about that yet, but that's a possibility. So let's get into it. First, this here is the Weather Risk Grains Twitter page, or X page now. And again, this is used mostly for my grain clients all around the world, and for the grain agricultural forecasting, of which I do quite a bit. And then, of course, this here is the Blue Sky page, where I do my operational weather forecasting for in the eastern U.S. hurricanes and snowstorms, the operational, the regular weather that most people use and enjoy. I will occasionally also post regular weather on the Weather Risk Grains Twitter page, but some people only like using one versus the other, so we've got two different locations here. Also on the website itself, we do have several products that you can look up under the shop page here. We have the 3-week forecast for the eastern U.S., we have the mid-Atlantic forecasts, we have the snow removal, the weather notification products, and stuff like that. All right, let's start out by taking a look at the ENSO conditions as of January here. So let me shrink this map down a little bit so you can see it. This is the CDAS graph analysis, and you can see it's reached a peak briefly of 1.5. Now it looks like it started to go up a little bit here the last couple of days. And then if you look at the actual sea surface temperature anomalies from the OISST. I think this is more accurate, and you can see, let me blow this up a little bit so you can see it. It also has a value of around minus 1.2, not quite 1.5, and now also it's begun a big tick update. So you can see that starting in December 1st, we saw this big drop off, and it's been very pronounced here. But like I said, it is starting to go up a little bit. And that's important because the various weather models show that it's going to come to an end very quickly. There's the CFS model, which is the model which got this correct. The only model which got this big drop off correct is clearly showing a rapid weakening as we go into January with this La Nina event. So since that has the hot hand, we should really stick with that. Now, here's the latest sea surface temperature anomaly map. And what I want to point out, this is the La Nina here, but notice how this La Nina is centered in the central Pacific Ocean. That's the coast of South America. So it's actually warming here. And you can see that the temperatures are much colder in the central Pacific. So this is a CP, Central Pacific-based La Nina, and a weak one at that. And those are pretty darn favorable in terms of winter weather for North America and the eastern U.S. We don't see a lot of them. And back in 2021, 21, 22, 22, 23, we had 3 La Nina events in a row, and they were all moderate. And so it's a very different type of weather pattern. Also, notice that the eastern Pacific is warming up significantly here. The warm pool has now moved off to the coast of California. And again, this was much, much colder only a month ago. And so most of the Pacific is turning warmer here as well. Okay, so I think this is what's really significant, the La Nina here. And also, I'm going to take a look at the sea surface temperatures in Australia too. It's really quite warm in and around Australia over the past several weeks. Okay, now this diagram talks about the central-based, or the Central Pacific, or the Eastern Pacific. Some people call it a central-based or eastern-based, but let's just call it by the official name, Central Pacific, uh, Eastern Pacific. So here's El Nino, right here. These two are El Nino. These are two La Nina. Here, the Eastern Pacific is when the La Nina is based right off the coast of Peru and expands westward towards the date line. See, the coldest water is right here off the coast of Peru. Now, in the Central Pacific El Nino, which is known as a Mordecai El Nino, these are very different. Here, the warm waters are clearly in the Central Pacific and not off the coast of South America. Now, these are also quite favorable for. They generally favor a not pattern which is not nearly as warm in the eastern U.S. during the winter months and a lot more winter storm chances. Now, here we have La Nina. This is the eastern-based or Eastern Pacific La Nina. And again, the coldest water here is off the coast of Peru. Now, the cold water extends out towards the date line, but the coldest water is clearly off the coast of Peru. It builds westward. This is a Central Pacific La Nina, also a Mordecai La Nina. Notice that the warmest waters are in the Central Equatorial Pacific, not off the coast of Peru, South America. That's exactly what we're seeing here. This is a textbook case of a Central Pacific weak La Nina event. If you want another diagram of it, let me call up this one. I can blow this up a little bit for you. You can see nicely here. So here, okay, El Nino, Eastern Pacific. See, right off the coast of Peru. This is Central Pacific right there. Here is Eastern Pacific La Nina, right off the coast, building toward the date line. This is Central Pacific. Again, notice very clearly pronounced cold water here, and this pool of warm water in the Central North Pacific, which again matches very much like we have right here. It's almost exactly the same. See this? Matches this very nicely, almost the same. So this is a Central Pacific La Nina event. Now, why is that important? Well, this is the overall pattern from November through March when you have a regular or Eastern Pacific off the coast of Peru, South America, La Nina event. And this is why you don't get big snowstorms when you have La Nina events for the most part, especially moderate or strong ones in the Eastern Pacific off the coast of Peru. You can see that you have a huge negative anomaly in Alaska that pushes down towards the northwest. So this anomaly corresponds or teleconnects, causes the atmosphere what we call teleconnection. This anomaly builds a ridge here. This favors the ridge here. If this wasn't here, the ridge wouldn't be there. And we also have a negative anomaly or a positive NAO favored in northeast Canada, Greenland. That's with a East Pacific. Let me change the color of this here. I want to change the color so you can see a little better. East Pacific weak La Nina. Now, here is Central Pacific weak La Nina. This is very different. This is very different, boys and girls, as you can see. So here, instead of the huge negative anomaly, we have a positive anomaly in northwest Canada. And you have a mean trough in the Ohio Valley, and you have some ridging in the northwest Atlantic towards Greenland. This is a very different weather pattern and a split flow between the northern branch and the southern branch. So these two jets get together and you get big storms in the Midwest and the East Coast. That's very different from this. Very different. Okay, that's what we're looking at with La Nina. Let's talk about our MJO, the Matthian-Julian oscillations. So this is what it was showing on December 18th and 19th. This is the European model. Now the yellow represents variations, but the solid lines, okay, the black line is the past. So this was as of December 18th, there is the 17th, and then the red line is the next 5 days, the blue line is 6 to 10 day, and the purple line is 11 to 15 and 16 to 20. So you can see the model had it, the MJO moving into phase 7 and then just briefly hitting phase 8 and then crashing back into the neutral circle. Here's the CFS from December 19th. Into phase 7, then all of it cuts right through the neutral circle, avoiding phase 8 and phase 1 and just barely making it to phase 2 and maybe not even then. So 8, 1, and 2 are the big cold signals for the eastern U.S. So if it doesn't go in there, this cold window possibility turns to shit and the whole thing collapses. Okay? Now, this is December 22nd and the 24th. Here's the European. Notice, see the thick black line? That's the mean. That's the ensemble mean. Phase 7, very briefly phase 8, then back in neutral circle. But if you look at the plots of the ensemble, the European has 50 different members in its plots. So the purple is the next 5 days, that's phase 7. The orange is day 10 to day 15. That's mostly, look at that, most of the orange here is in phase 8. And then in the 11 to 15 day, you see the blue colors. Now you have a lot of them neutral circle, some of them are phase 1, phase 2. So, but the next 10 days, you can clearly see it favors phase 7 and phase 8. Now, this is, again, you can see this is the ensemble mean here, but this is longer range. This just goes a little further out in time than this does for the next 2 weeks. Again, briefly, phase 7, the neutral circle. Now, this is the new stuff from December 26th, today, or I could say Thursday. Here's the European model. Notice the line is now completely out of the neutral circle. Phase 8, phase 1 into phase 2. And most of these yellow lines are out of the neutral circle as well. Here's the GFS, phase 7, phase 8, and phase 1. And here's the CFS, phase 7, phase 8, phase 1, phase 2, and then phase 3 by January 24, a month from now. And to show you what this looks like extended range, here's the European plot from December 26th. And again, notice the black line is right along the edge, but most of the orange and the purple dots are out in the middle of the diagram, which means the MJO was fairly strong here. See how most of the orange dots are outside of the black line to the left of it? Look at the blue dots. Most of them are out here in phase 2. So a lot of data suggests that this, we're going to be phase 8, 1, and 2 here for most of January. Now here's the extended CFS. There we go. We can see on CFS, we're moving into phase 7, and then end of the month, we're phase 7 to phase 8, and then we go into phase 1 by January 15th to the January 20th. So that's also a slow, pretty progressive moving track here. Now, why is that important? Well, this is what happens in January. Temperatures, precipitation. Look how cold phase 8 is. Phase 1, phase 2. Cold everywhere. The precipitation, fairly dry in 8, okay, and then pretty wet in the southeastern states and the Midwest. This can be a snowstorm pattern for the Northeast, and in phase 2 as well. So, and this also shows you the schematic of how this is supposed to work here. This is phase 7. This is December, January, February, and you can see we are in phase 7 now. There's a bit of a ridge here, and then we go into phase 8. You get a big negative anomaly. Phase 1 off the coast. Phase 2. Midwest and New England. So these are the stormy phases, phase 8, phase 1, and phase 2. Phase 8, phase 1, and phase 2. That's what we want to keep in mind. Okay. Let's talk about teleconnections. The teleconnections are significant relationships or links in the atmosphere between weather patterns and weather phenomena, such as El Nino or La Nina, or the Indian Ocean dipole, or the NAO, or, in this case, in North America, we have 4 general teleconnections we look at. There's the Pacific side, which is the Eastern Pacific Oscillation. When it's negative, you have cross-polar flow from Siberia to Alaska to the U.S. When it's positive, you have mild Pacific air coming in. When the PNA is positive, you have a big ridge helping to bring in the colder air. When it's negative, you have got a trough on the west coast and a lot of rain, and you get a ridge in the eastern United States when it's mild. On the Atlantic side, you have the Arctic Oscillation. When it's positive, the polar vortex is far to the north, and that generally pulls the cold air and keeps it in northern Canada. And then on the Atlantic side, eastern Canada, we have the negative NAO, the Greenland block. Or, if there's an upper low in Greenland, then you have a positive NAO. Okay. So, this here is the Pacific side. So here's the EPO, as you can see. Let me bring this front. There we go. So the EPO, this is where we have been. We've been positive. Now the models take it to January 1st, slightly negative, and then they keep it negative. And then you split. Look at the wide range here. Some are way negative, some are strongly positive, and many in between. Now here's the PNA pattern. You can see it has been positive, it drops down to negative, and then it begins to work its way back towards positive by the middle of January. And if we look at the trends, we can see here, this is the Arctic Oscillation for the next 35 days. Look, the green colors are negative anomalies. And the darker the green, dark towards blue or purple, that's -5. So for the Arctic oscillation, the vast majority of the data shows it turning negative early January and continuing right through most of the month. The NAO is showing the same sort of thing. Now, mostly confined through, let's say, January 20th. After that, it's more hit and miss. But in here, it's a pretty good negative NAO combination. All right, on the Atlantic side, here's the Arctic oscillation. It's been positive, now it drops down to negative, and then most of the models have it staying slightly negative through the first 10, 15 days of January. And here's it should be the NAO. There should be the NAO have the PNA, so I have to get rid of that. But it's also quite negative. The Greenland block is also turned to negative as well. And you can see that here. Here is the EPO, and you can see again how generally negative it runs for the next couple of weeks. And then here's the PNA pattern, where it stays generally positive. A little bit of negativity towards maybe some kind of West Coast trough at the end of January, but that's way, way out in time. The other point here to talk about before we get to the models is the polar vortex. Here's the European ensemble spread of the 50 different models. You can see that this thick blue line is the ensemble mean and is generally weakening at a pretty good pace here by by January 23rd, right through the end of the month. That would indicate potential weakening of the winds around the polar vortex, which means it's easier for the polar vortex to fracture and get pushed deeper into the Canada region or deeper into northern Europe, away from the North Pole. So when the winds here are weaker, it means potential breaking up of the polar vortex, which is, what you want to see if you like winter storms and you like cold in the eastern U.S. Indeed, here's the GFS. You can see this is where it is right now, December 26th. It's just one big ball here. And the time we get to January 8th, there's clearly a stretching, and it looks like a second center is forming, like it's going to snap here, and that's that's what it shows. Now the European is not showing that. This takes us out to January 9th, and you can see that the vortex is intact here over the North Pole. And there's a lot of warming in Asia and Central Asia at the high levels at the top of the atmosphere, and we're talking about 10 millibars, almost the edge of space here. But they do not have things splitting like the GFS does. It doesn't have that. So we'll just have to wait and see which model is going to be correct here. All right, let's get into our models here quickly. Okay, so this now is the European ensemble now for Friday night. And you can see the trough coming through right through here. Now look at the howling Pacific jet. This is all Pacific jet stream energy. One main trough, another disturbance here in Wyoming and Idaho, in Utah, then another one approaching British Columbia, one in the northern Pacific. So boom, 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 boom. Now we have a ridge here, which is developing nicely, and then it becomes a block in northern Canada. So what happens is you get the low pressure area tracking up into Michigan and Illinois, not Michigan, but Illinois and Iowa, pretty good rains there. And then the low tracks up into the St. Lawrence Valley. And the high is here, and you're getting southeast winds bringing in the mild air along the East Coast. All right, here we have now December 29th, 30th. The trough is now negatively tilted, so the surface low is really intensifying here. And you can see it's quite strong in the Ohio Valley. The highs off the coast, very strong south winds. Well, the winds aren't strong. I just meant persistent. That's the right word. Persistent southerly winds feeding the moisture and the low-level humidity from the Bahamas and Florida right up into southern New England. So that produces a lot of heavy rain when this low-pressure area tracks through the Ohio Valley and goes up into the eastern Great Lakes. The cold front comes through on Monday morning. Monday or Sunday night, and with rain, maybe some thunderstorms as well. This is a pretty strong system here, negatively tilted, so it can do some damage. And now there's another system coming in behind it. Now this is going to be a big system here for January 2nd or 3rd. It's going to drop right into the trough. And here's your ridge, because the trough is here, your ridge is here, but notice you now have more of the blocking developing in northeast Canada, Greenland. So this block is really, really important when we get into the pattern here. But watch this next system coming in behind it here in Washington State. This is on December 29th into 30th. Once this trough is gone, this one becomes the big one. Okay, so now this is December 31. So the first trough is now in New England, and the system which was in the Pacific Northwest has moved into Missouri and Kansas and a place like that. So as you can see, there's the first system. Here comes the next one coming in. Now, this is a colder pattern, but it's not really that cold yet. So most of this in the Midwest initially looks like rain on Monday, December 30th into Tuesday, December 31. And then it tracks up from Missouri into Ohio, then up the St. Lawrence Valley in this direction here, pulling mild air again into the East Coast and followed by rain. Okay. Then that system intensifies this system here. Make sure you know what I'm talking about. Yeah. This system really intensifies the surface low right here. And we end up getting this thing. Look at this. Whew. Very impressive. Okay. So unfortunately, there's not enough cold air even in New England. So this is primarily a rain event, even for New England, well inland. But a lot of wind coming behind it, and the temperatures really crash on January 1st and 2nd, and the warm spell comes to an end. So we go back to normal temperatures for early January. In terms of the upper air map, there's your negatively tilted trough. There's your block here, okay, in northeast Canada, okay, and you don't get much ridging on the west coast, and the trough axis is right here across the Ohio Valley. All right? Okay. Excuse me. So here, now that takes us to, excuse me, just skip the slide here. Okay, now we're going to January 2nd and 3rd. All right, here this map, the negatively tilted trough here on January 1st, upper low, runs up against the blocking pattern, and the system moves very, very slowly. Here, you now have a deep closed upper low in southeast Canada. The trough is along the east coast. You have a nice ridge in the Rockies pouring the cold air in, a huge block in northeast Canada, Greenland. All right, look at the strong surface winds really bringing the cold air in. I mean, this temperatures plunge. This is January 2nd into January 3rd. I mean, that's a nice looking map here. A lot of cold wind here coming in like that. And you can see the upper air map looks pretty impressive as well. Now, what happens beyond that? Well, the trough moves off the coast. The block remains in Greenland. And we have some sort of disturbance here on January 5, right in the Mississippi Valley. Let me see if I can blow this up for you can see it a little more. Okay, bring front. There it is. You see how you got a kink there in the isobars? Right here. Right there in the height, not the isobars, the 5 millibar height lines. Geez, it was late at night. Sorry about that. Right here, Mississippi Valley. Now, I don't know if this is going to be enough to cause surface to develop on January 6th. I thought originally it might be. I'm not certain about it now. In any event, there's your 50-50 low, a big ocean low in southeast Canada. Here's your block in Greenland, right? And another one in the western Arctic, and a nice ridge on the west coast. So you're getting a good flow of cold air coming in. And like I said, there's some sort of disturbance here. Will it cause something to develop? I don't know. It might. I just don't know at this point. That's January 6th. Right? Now, this is January 7th into January 8th. Here, you have a very deep trough which has been pulled back to the west. As you can see, the polar vortex is coming southward on January 8th. Right? You have a pretty strong ridge on the west coast. Now, let me shrink this a little bit here. There you go. A nice ridge on the west coast. So you have a strong cross-polar flow. Look at the block bringing the cold air in from Siberia into the central and southeast Canada. This is a pretty significant signal for something big to happen on January 7th or 8th. And the extended model, this is the European model here from December 26th. This is valid January 8th. There's the winter storm in southern Illinois, major snowstorm for the Midwest. Then it reaches the East Coast. You get a snowstorm from the Northeast, from Virginia into Maine and Boston. We'll see. Maybe. And that is also showing up on the GFS. This is the 12Z GFS is showing the same sort of thing. Okay? Same sort of thing. So, all right. In summary and then in conclusion, like I mentioned, these are the points we covered. Mild and wet for the next 5 days. Major pattern change coming January 1st after that big Ohio Valley low goes up the Ohio Valley, the eastern Great Lakes, and then into the St. Lawrence Valley. The winds, the cold air comes back in. The pattern looks like it is going into phase 8 and phase 1, not the neutral circle. And that means there's going to be a window on the eastern United States, East Coast, of a significant winter storm, maybe even two of them, January 6th and January 12th. I know this is a long way off, but, I'm not afraid about talking about the patterns and see what's going on, see what we can figure out. And sometimes it's going to be right and sometimes it's going to be half off. But this is how you learn. You push the envelope. That's it, really. And then the favorable pattern here may last through January 20th, like I mentioned earlier. All right, that's the video. I know this is a long one, but hopefully you enjoyed it and you learned something. We'll do another video next week unless something really dramatically changes. But until then, this is Meteorologist, the DT from Weather Risk. You can see me over on the website, on the Facebook page, and on the Blue Sky social media page and the X or Twitter social media page, Weather Risk Grains. Thanks for your time.